In this video, I'm going to talk about overloading functions. Sometimes you want to create two or more functions that perform the same task but use different parameter lists. So C++ allows you to give the same name to multiple functions as long as their parameter lists are different. And to explain this concept better, I'm going to write a function that is going to get one argument and return the square of the argument. So for that, I'm going to define a variable. Let's say int x is equal to 2. And I'm going outside of the main function and write a function definition. So int get square, this is going to be a name of a function. And in the parameter list, I'm going to define my parameter. So let's say, since we are dealing with integer numbers, so int and the name of my parameter. So it's going to return the multiplication of number by itself, and this is going to be a new value of number, and we are going to return number. Now I'm going to call this function. How do we call the function? We write the name of a function. So get square, and as an argument, I'm going to pass my variable, which is x. Now I want to print out the output, cout, and give std end line, and write my prototype. So how do we write our prototype? We write the return type of a function, which is int, the name of a function, which is get square, and in the parameter list, I'm going to write the data type of a parameter, which is int. So when I run this program, what happens? Let's see what happens. So the output is 4. This is what we were expecting, right? So the value of x is 2, and it's going to return the square of 2, which is 4. But so this function returns the square of integer number. So does this function work for variables of different type? For example, double. Let's say so double, let's say y equals 2.2. And now I'm going to just copy and paste, and instead of x, I'm going to pass y. So let's see what happens now. When I run this program, the output is 4 and 4. The first function call, the output of the first function call is 4, which is correct, but the return value of the second function call is 4, which is not correct. Why? Because the square of 2.2 is 4.84, but here on the console you can see 4. Why is that? To explain this situation, I want to debug this program. So I'm going to add a breakpoint and click on debug here. And let's split our screens. And here we have watches. So watches shows the local variables of functions. So here we are in the main function, and the local variables of main function are x and y. Now I'm going to step into every line by using this button. I'm going to press on it. As you can see, the value of x is 2. Now I'm going to step into again. As you can see, y, the value of y is 2.2. The value of y is 2.2. Now, so I'm going to continue to step into every line. When I step into this statement, there is a function call, and the argument is x. So it's going to branch to the function, and the number is going to take the copy of x, which is 2. and return 2 times 2, which is 4. So let's do it. And as you can see, number is taking the copy of x, which is 2. And the new value of number is going to be 4. And it will be returned. Okay. Next, there is another function call, but in this case, the argument is y. And y is, the data type of y is double, and the value of it is 2.2. But the data type of number is integer. So number is going to take only the whole part of a number, which is 2. It's going to omit the decimal part, the numbers after the point. So let's see. So the value of x is 2, okay, and the value of y is 2.2. Now, when we step into this function, or into this statement, let's see what happens. As you can see, the number is taking the copy of y, but since the data type of the number is integer, it's going to take only the whole part, and it's going to omit the decimal part. And that's why it's going to multiply 2 by 2, and we can see on the console 4, but not 4.84. So let's continue. As you can see, here we have 4. So how can we fix this problem? Well, we may think to write another function that is going to accept decimal arguments this time. So let's do this. I am going to exit the debugger and write another function that is going to accept double arguments. So double get square, and since we are going to get this double argument, let's give another name, get square and double. Let's say double. And in the parameter list, the data type of a parameter is going to be double, so that it can take the whole number, not only the integer part. So double, and let's say num. Okay, you can give the same name actually, since they are going to be destroyed in the memory. So num times num will be the new value of num, and we are going to return num. So now I'm going to write the prototype of this function, double get square double. And in the parameter list, I'm going to write the data type of a parameter that I defined, so double. And now, in this case, I am going to call this function, get square double, the function that I wrote here, and I'm going to pass y as an argument. So when I run this program, let's see what happens. As you can see, we have a correct result. Why? Because the data type of a parameter is double, so it's going to take the number 2.2, but not only the whole part, but the whole number 2.2. And let's debug this program. So I'm going to click on debug. Okay, so now I'm going to step into every line. So the value of x is 2. Now I'm going to step into this line, and let's see. So the value of y is 2.2. Then it goes down. Let's step into this function call. So the value of number is 2. Why is that? Because it's going to take a copy of x, and the copy of x, the value of x is 2. So it's going to multiply 2 by 2, then the new value of number is going to be 4. So let's tap into this. As we can see, the value of number is 4. And this value will be returned to the place where it called. So on the console, we are going to see 4. Now we are going to step into this, this line. And here we have another function call. This time we are calling get squared double. As an argument, we are passing y. So what happens? It branches to the function, and the data type of number is double. So it's going to take 2.2. As we can see, 2.2. Now let's tap into again. As you can see, num times num, which is 2.2 times 2.2 is 4.84. Here is the value. Here is the value, and then it will return this value and print out on the console, as you can see. As you can see, we have two functions, get square and get square double, and these functions are doing exactly the same thing. They are returning the square of an argument. The only difference between these two functions is that here we have different parameter lists. So here in the parameter list, the data type of a parameter is integer, but in this function, the data type of a parameter is double. So in this type of situation, C++ allows us to overload functions, meaning you may assign the same name to multiple functions as long as their parameter lists are different. So let's overload these functions. So we can give exactly the same name for these two functions. So I can say get square and get square. So let's change here as well, get square and get square. And let's run this program. I'm going to run this program. Okay, I'm going to run this program. As you can see, 4 and 4.84. We don't have any errors right now. And as we can see, we have two functions with exactly the same names, get square and get square. So how does C++ know which one is which? It distinguishes functions from each other by using function signature. So what is function signature? It is the name of a function and its parameter list. So to explain it better, I'm going to take a screenshot of these two functions and show the function signature and explain function signature. So here we have two functions, the first function and the second function, and they do the same thing. They perform the same task. They are going to return the square of an argument. And both of these have function signatures. And what is a function signature? Function signature is the function name, get square, and the parameter list. And as you can see, it has one parameter and the data type of a parameter is integer. So it means it's going to accept integer values. When it comes to this function, the function signature is the function name and the parameter list. But in this case, we have a parameter and the data type of this parameter is double. So it means it's going to accept double arguments. So let's say we have something like this, int x int x is equal to 2, and we are going to call getSquare function and pass x. And let's say std cout. What happens now? When the compiler comes and says there is a definition of a variable and the data type of it is integer, then we have here a function call and the argument is integer. So C++ is going to branch to getSquare function that is going to accept integer. So it's going to branch to this function. And let's say here we have another definition, double y equals 2.2. And we are going to print out cout get square, and as an argument we're going to pass y. So what happens here? So when double argument is passed to getSquare function, a function with double parameter is called, and the function with double parameter is this function. So this is the way how C++ distinguishes two or more functions that have the same name. The C++ is going to distinguish according to the function signature. And what is the function signature? It is the function name and parameter list. Function name and parameter list. So they can have the same names, as we can say getSquare and getSquare, but the parameter lists are different. That's why it's acceptable to use these two functions with the same name. So one more thing that I want to mention here is that we have to be careful. Function signature, as I said, function signature includes the function name and the parameter list. So functions can have the same names, but they have to have different parameter lists. They have to have different parameter lists. But we have to be careful that the function signature is only the name and the parameter list. It doesn't include the return type or return value.